Hey there, Mr. Wilford here. I just wanted to go through Chapter 5, Section 5 with you a little bit and talk about complex numbers and roots. And really, when we talk about complex numbers, what we need to discuss is the imaginary number I. And the imaginary number I is defined as the square root of a -1. You'll notice a lot of times on your calculators, if you try to take the square root of a negative number, that you'll get an undefined answer. And so we need a way to deal with that. And the way that we're going to deal with that is use the imaginary number I. So for example here, a couple of examples. The square root of a -2, really if you take an I out of that, that changes it to a +2 inside the square root. So it's really I times the square root of 2. When we have the square root of -4, if you take an I out, that changes it to a +4, and so the square root of +4 is 2, so we end up with 2I. The thing to remember here is that I squared is always equal to -1. So a couple things to remember when dealing with imaginary numbers. First of all, treat I like a variable, even though it's an imaginary number. We want to treat it like a variable. And when you have I squared, whenever you see I squared, you want to set that equal to a -1. So when simplifying expressions with square roots of negative numbers, like I mentioned, we're going to take an I out first, and that's going to make it positive, and then we can simplify the radical from there. A couple of examples here. 3 times the square root of -16. We're going to take an I out of here, and that's going to change that to a +16 inside there. Square root of 16 is 4. It's a nice integer number, and then 3 times 4 will give us 12, and then that square root of -1 turns into an I. Be careful with the negatives, so if we have a negative outside of the square root of a -75, here we're going to take an I out, and then we're going to break 75 into 25 times 3 is 75. Square root of 25 is a nice integer number that turns into 5. And the square root of 3 is going to stay inside the radical. So we end up with -5 times the square root of 3i. A couple different ways you can write that. Typically, you'll see it like this, -5i times the square root of 3. So you have to be able to deal with imaginary numbers every once in a while, and that's kind of how you do that, and that's where they come from, is the square root of a negative number. So then that leads us into what we call the complex number system. A complex number is really a combination of real numbers that we're used to and imaginary numbers. So you can see here in kind of a Venn diagram, we have real numbers that sit over here. This involves both rational and irrational numbers. And then we have our imaginary numbers over here in this circle, and you can see they're not overlapping. They're two separate things. But in the middle, we have a combination then of a real number plus or minus an imaginary number. So these are examples of complex numbers. So we have a real part and we have an imaginary part. Some of the problems that you're going to see in this section, they're going to set two complex numbers equal to each other, and really what you're doing is you're setting the real parts equal to each other and the imaginary parts equal to each other. And then for these problems, they have some variables in them, so you'd actually have to solve for that variable. Then the last thing we have is something called a complex conjugate, and this is really taking a complex number, and then if you change the sign in the middle, if you change the sign of the imaginary part, you end up with its conjugate. So as an example here, and they kind of switch this around a little bit, it's better if you can write it as the real number first and then the imaginary. So -15 plus 2i, its conjugate is -15 minus 2i. Here we have just a -4i, its conjugate would be plus 4i. If you have any questions, please let me know. Thanks.